Hello, this is Mrs. Leonard, and you are watching the video for Earth Science Relationships. These are the notes that we took on September 18th, on Monday. And to start off, the materials that you're going to need are the guided notes worksheet that you should have picked up in class, and a pen or a pencil, and that's all you need. So to start off, the learning objective, you want to make sure that you write that at the top of your notes, as well as the date. The learning objective is the student will be able to state the relationship between two variables in earth science. So we're not talking about relationships like boys and girls and things like that. We're talking about relationships between two variables. A variable might be temperature, or it could be the tilt of the Earth's axis. Something, in other words, that varies or changes. So there are 4 different types of relationships: direct, inverse, independent, and cyclic. So these are the 4 different relationships that you will hear us talking about in earth science this year. So the first one that you should know about is a direct relationship. And a direct relationship, which is what we'll write right here, is a relationship that when x gets bigger, y gets bigger. So remember, the x-axis is always down here on the bottom of the graph, and the y-axis is always over here on the left-hand side of the graph. I always think of this as the y is high, and so I always remember that. So as x gets bigger, y gets bigger. They're directly related to one another. So an example, the relationship between age and size is a direct relationship. And so we would say as your age gets bigger, your size gets bigger, at least up until you reach maturity, which is right about now, or when you're seniors in high school for the most part. So you should draw a line graph. Your graph for a direct relationship is going to look like that. It's going to increase as you go from left to right. So the second type of relationship is an inverse relationship. And an inverse relationship is a relationship where as x gets bigger, y gets smaller. Okay. So again, x might be down here, okay? And in this example, the relationship between the time spent at the mall and the amount of money in your pocket, this is an inverse relationship. So if we're talking about the time spent at the mall, that might be down here on the x-axis. And if we are talking about the amount of money in your pocket, that would be over here on the y-axis. So I might just abbreviate this a little bit, use a $sign for money in pocket, just so I have enough room to write this on that axis. And an inverse relationship means it's going like this. So it's starting at the top and it's going down as you go across to the right. So one of the ways that you can use to try and make sense of this is to put numbers on here. I saw people doing this on their pre-assessment. So we're going to put some numbers on here. So I usually just try to go up to 4 or 5, try to spread them out evenly the way I did here. And then do the same thing on the y-axis. Start at 0, and I usually just go up to 4 or 5, okay? Now, when we're so whenever you see a graph that doesn't have numbers like this, and you're looking to see what the relationship is, put numbers there first. That's the first thing that you should do. And then the second thing that you should do is draw 2 points on this line. One on one end of the line and one on the other end of the line, okay? And then you figure out, well, what is happening at each of those points. So for example, in this case, at this point, how much time have I spent at the mall? I have to follow that straight down and I see that I've spent about let's say this is an hour, okay, 1 hour. I've spent 1 hour at the mall. And how much money is in my pocket? Let's say this is dollars. $5. Woo! So I have $5 in my pocket after spending 1 hour at the mall. So now if I go to this point, how much time have I spent at the mall? 5 hours. And if I follow that straight across, how much money do I have in my pocket? I only have $1. So think to yourself, does that make sense? And it does, right? The longer I'm at the mall, the more money I'm going to spend on things, and so the less money I actually have in my pocket. And so as time goes up, as time gets bigger, as time increases, the amount of money in my pocket gets smaller. And so that's why this is an inverse relationship. Okay? The third type of relationship that we're going to talk about today is a cyclic relationship. Cyclic relationship. I'm going to underline these in my notes so that they stand out. Okay. Cyclic relationship is a repeating pattern. Okay, and most of the relationships that we have in earth science are cyclic. So some examples: repeating high and low tides, temperatures go from cold to warm and then they'll go back down to cold again, and the phases of the moon. And a cyclic relationship looks like this. It goes up and down and up and down and up maybe again, right? So that's a cyclic relationship. And then the last one, finally, is an independent relationship. An independent relationship is where X has no effect on Y. Okay? And this is going to be a straight horizontal line. It means that one variable has absolutely no effect on the other. So when I draw this line graph, it will look like that. Straight horizontal line all the way across. So in other words, this could be something like as time goes on, what do I want to say? As I did this one in class, as Mrs. Leonard height increases, Jose's grade stays the same, right? So it shouldn't matter how tall I get. It shouldn't impact, or it should have no effect whatsoever on Jose's grade. Okay, so usually these are things that are not related to one another at all. They don't bear any sort of relationship to one another. Okay? Okay, so if you missed all of Monday's class, then you're going to want to watch the next video on the output page for relationships. Okay? If you have not already taped this into page number 5, you should make sure that you tape that into page number 5, and you'll probably have to fold it up at the bottom so that it fits. All right, that's it. I hope that this was helpful.